The next topic is filtering, and I think this is more interesting than noise. So before talking about the actual filtering operation, let's try to understand some of the basic concepts of which will be required. So if you go by definition, image filtering is what you do is you take a function which is called a kernel, and you take like a small patch from your image, and you just compute like you can say like a linear combination of the function with the image patch, and that will give you some value. So it's kind of an operation which is performed using that kernel function on a neighborhood of an image. Okay, and this is like a very general formulation for image filtering. In this case, I represents an image. Okay, so M and N are like any particular like your grid locations in your image space, and what you do is you look into the neighborhood of that location, which is centered at M and N, and the radius of that neighborhood that's defined by these two parameters, K and L. So how big that neighborhood will be. All right. And what you do is you have this filter function. You compute like a combination, or you can say linear combination of this function with the pixels in this neighborhood, and you do some kind of averaging, and that gives you like some kind of response. So this general formulation is called image filtering, where I is your image, F is your filter, and H is output, which is called like the filtered image. Okay, so M cross N are like the 2D coordinates in your image space. And again, K and L are like a 2D coordinates which define like how big your neighborhood will be. Now, the question is, I think this is a very basic question, like why we need filtering. And later you will see like a lot of different applications of filtering, even in like when you try to study convolutional neural networks and deep learning, you will see like the basic operation which is being performed as filtering. So that's one thing. But other than that, like that's more recent. In earlier days, people used to use image filtering for enhancing images. It could be if you have noise in your image, which you just looked in the previous set of slides, right? There will be noise in your image. So how to remove that noise? If you have to perform resizing of your images, then again filtering is used. And if you have to perform like different kind of operations, for example, if you want to increase or decrease contrast or any other image manipulation, filtering is very useful. Okay, so that's one use which is called image enhancement. Then the second is like if you want to extract some meaningful information from images, then filtering is very important. And this correlates to like when I was talking about how filtering is used in deep learning. So we use filtering to extract the useful information which is used for making predictions. Okay? So this information could be either like texture present in the image, it could be edges, it could be like distinctive points, and many other interesting features. And again, you can use like to detect some patterns, and this also correlates to extracting useful information. You will see like how these two are very related to each other. And for detecting patterns, template matching is like one interesting use. And I think in the first lecture, we were talking about how we can use template matching for object detection. So we're trying to detect patterns, right? And there, if you remember correctly, we were using correlation. So that correlation is actually a filtering operation.